Okay, good morning, ladies and gentlemen. Today we're continuing our look at being able to describe locations within a distribution. And today we're going to look at the idea of the z-score, the standardized score. The z-scores are based on the idea of standard deviation, which we've discussed before. And we can see the two formulas for standard deviation, and you can see they are very similar. One difference being this having to deal with the difference between a population, calculating them for a population, or calculating them for a sample. If you recall correctly, a population is the entire group, a sample is the portion of the group. So when we're dealing with the population, we're using the letter mu for the mean, and we're using the letter sigma, or the lowercase letter sigma, for the standard deviation. The difference when we look at a sample is the mean becomes x bar, and the standard deviation becomes s sub x. And then we'll see a slight difference in the formula, where the population uses the denominator of n, where the sample uses the denominator of n minus 1. Now, these formulas, as we discussed later, are very difficult, time-consuming to calculate. For the most part, however, we will be given these values, or we will be able to use the calculator. So looking at a z-score. So let's move on and look exactly at the idea of a z-score. Okay, a z-score is a standardized value. It's very important to remember that it has no units. Standardized scores have no units, and we see that in this formula here because we're dividing numerator and denominator have the same units, and so they would cancel out. Z-scores allow us to measure the distance between a data value and the mean in terms of the standard deviation. This can be allowed, so we have standard deviations, so standard deviations below and standard deviations above. Positive z-scores signify values that are above the mean, and negative z-scores will signify values below the mean. We're going to look much more later on in depth to z-scores, especially when we tackle the idea of the normal distribution. However, understand that z-scores can also help us calculate much more exact percentiles than we could just by looking at those distributions. So let's go ahead and put this into practice, and let's look at, one moment. So looking at z-scores in terms of, z-scores as we look to the percentile. So here we have typical normal distribution, which you probably can recall from before. And we have in the middle, we have our mean. And each of these lines that you see going out is a standard deviation. So this would be mu plus 1 standard deviation. This is mu plus 2 standard deviations. And this is mu plus 3 standard deviations. Going the other way, we have mu minus a standard deviation, mu minus 2 standard deviations, and mu minus 3 standard deviations. So if we apply this idea to a z-score, remember z-score is the number of standard deviations from the mean. So if we're on the mean, our standard deviation is our z-score would be 0. We're 0 standard deviations away from the mean. Going to the right, each sigma tells how many standard deviations we're counting away. So here's counting 1 standard deviation, 2 standard deviations, 3 standard deviations. These are positive because we're adding them on. Now going in the other direction, we get negative z-scores. -1, -2, -3. And these are z-scores. Z-scores will allow us to compare groups, data that might be related but aren't exactly the same. Different but related groups by removing the units and giving us an idea how things are compared to the group as a whole. Okay, so let's try a couple of practice problems here. Here is number 9, which was asked to do in your asynchronous work on Thursday and Friday. So we know during the baseball season 2004, the mean number of wins for Major League Baseball teams was 81. Was 81 with a standard deviation of 9.6. So if we're looking for the standardized score for the Nationals, who won 96 games, so Z is going to be the formula X minus mu over N. Now we know X is our X value, so that's going to be 96. Mu is 81. Sorry, it's not over N, it's over standard deviation over 9.6. So 96 minus 81 is 15 divided by 9.6. And so the Washington Nationals are going to have a Z-score of 1. Sorry, my stylus is misbehaving at the moment. 1.562. So what this is telling us is the national win total, the Nationals' number of wins is 1.562 standard deviations above the mean. Okay, so another question. Let's take a look at a different one, slightly different idea. We're looking at the height of the 25 students in Mrs. Navard's statistics classes, which has a mean of 67 inches and a standard deviation of 4.9 inches. Go ahead and switch colors here. It's purple. And we know that we're looking for the Z-score for Boris, who is 76 inches tall. So the Z-score for Boris is still going to use the same formula, X minus mu over sigma. So we have 76 minus 67 over 4.29. This is 9 over 4.29. It's going to be about 2 point something, but we'll go use a calculator and get a much more accurate answer. And we get 2.098. So this is telling us that Boris's height is 2.098 standard deviations above the mean of his class. I will tell you, and we'll look at this later on when we look more into normal distributions, that does make Boris exceptionally tall for his class. Okay, and that, ladies and gentlemen, is the idea of Z-scores. So we have talked about percentiles. We've looked at cumulative relative frequency graphs, and we have looked at Z-scores. So we're going to come back to which states are rich, which is on page 82 of your textbook, which was another set of questions that you were asked to discuss and look at in asynchronous work on Thursday and Friday of last week. Here we're looking at the median household income of the 50 states. And you can see the graph, and they've also provided us some of the data, giving us the order and the mean, mu, and the sigma, standard deviation sigma. So our first question we're given is, what percentile is North Dakota with a median household income of $55,776? So if we look, that's going to have to go back to our cumulative frequency graph. We're going to look for 55,766, which is probably right about here. We'll go up to our graph. And then we will go over. And it looks like I sloped down, so we're going to do that. Okay, so it looks like we're right around 75%. So the median household income of North Dakota, I'm going to use the abbreviation here, ND. North Dakota is at, remember percentiles, we use the word at, is at the 75th percentile. Okay, so moving on, we move on to our next question. I'm going to change my color again. We're asked to estimate and interpret the first quartile of the distribution. If you remember, the first quartile, Q1, is at the 25th percentile. So we're going to look for the 25th percentile, which I'm guessing is right about there, a little higher. So we're going to go all the way across and down. It looks like so the 25th, so Q1 of the distribution looks like it to be $45,000, which means 25% of the states have median incomes less than 45,000. Okay, and that brings us down to our last question. Maybe we'll extend the page a little bit. We're asked to find and interpret the standardized score for New Jersey, which has a median income of $66,692. So we're going to look for our z-score. So our z-score is going to be x minus mu over sigma. So that's going to be 66,692 minus, go back up. So we're looking 51,742.44. So minus 51,700, got it. 742, I did remember it. 742.44 over our sigma, which remember is 8,000 something, 8,210,642, 8,210.642. So again, we'll use a calculator. I'm not going to do that math in my head. So 66,692 minus 51,742.44 gives us 14,949.56, or 56, divided by 8,210.642. 8,210.642. We'll get a standard deviation of 1.821. So this tells us that New Jersey's median household income is 1.821 standard deviations above the country's mean. So that does put New Jersey among some of the more wealthier states in this union. So I hope, ladies and gentlemen, that gives you a good idea of z-scores and again, a little bit back going on percentiles from yesterday. And you're going to have some practice exercise. Your practice set this evening is from your textbook. Please look on the Google Classroom to obtain it. And come, when we return to class Thursday, we will continue this exploration, getting more into some practice in the applications of percentiles, cumulative relative frequency graphs, and z-scores. Thank you.